Welcome dear viewers and students. In this sessions we are look about graphic principles and geometrical constructions. In previous video sessions you learned about the introduction about engineering graphics and drafting, and also what about the tools we are handled in engineering graphics. But even though we are using tools, but we have to learn the basic principles and constructional methods in this engineering graphics and drafting. Here graphics principles and geometrical constructions. In graphic principles, that is principles of graphics we are named. Any language to be communicate should follow certain rules so that it conveys the same meaning to everyone. Similarly, drafting practice must allow certain rules if it is to serve as means of communications. For this purpose, Bureau of Indian Standards, so this we are named as adopting the international standards on code of practice for drawing. It has formulated certain rules and published through BIS. So the other foreign standards are DIN, ANSI and BS. But if you take about any graphics principles, so it is similar how we are learning the language. Suppose if you take English, first you have to learn about the alphabets. So and that is alphabets is nothing but in symbols. So that you have to learn alphabets. So after forming of group, so if you are a couple or you have to take two alphabets and forming a pronunciation. In similar aspects in our universal language of this engineering graphics and drafting, we have to follow certain rules, that is for communications. Here I classified as in 4 divisions. The first one is drawing sheet layout, the second one lines and lettering, then dimensions. These four categories are most important while you doing any type of drafting. So that is why we have to look before going to practice any such exercise. First we have to learn about a drawing sheet layout. Already I shown is that in instrumentations how the tools are working, but in that drawing sheet already I told how the drawing sheet, what about the size of the drawing sheet, so how to select a drawing board and etc. But drawing sheet layout, you have to be draw the border line. If you take any drawing sheet, so in the drawing sheet you have to draw a border line. So that border line, why I am telling this border line is important. Suppose if you want to continue, you have to draw any draft, that is any object you have to draft on the paper. So after some more times you have to unwind, that is you have to incomplete and you chosen, you have to do it in another day. In that again you have to follow, you have to fix your many drafter scale is parallel or coincidence with any one of the borderline edges, then to continue. So it will looks the regularity and also uniformity and shows the proper size and dimensions, size dimension as well as locations. So in such case we are using this drawing sheet layout. Not only that, if you are doing any drafting, in the drafting in any one of the corner you must show the details. What details we have to give? The details nothing but who is the developer, who is the drafter, who do this chart, who do this drawing, like many numbers. Not only that, what type of drafting, whether it is following, so first angle or third angle projections, we have to learn in further sessions. So those details you have to enter on which dates and the entire details about the developers, that is drafter, and the details about the objects that should be produced in the right side from the bottom. So there are many types of drawing sheet, but I am not shown here in entire, but you have to follow by looking in some other articles. Here we have to learn about that is how we are using this drawing sheet layout. Yeah, I just erased this. Yeah, first we have to draw a border line. Yeah, if you take any paper drawing sheet, in the drawing sheet you have to draw a border line. That should be, you have to keep this scale, a scale in the left end. Yeah, from that you have to measure 20 mm. So, from the 20 mm you have to draw a line, and also from the bottom 10 mm. So, we have to draw a border. Yeah, here I chosen red color. Yeah, I just switch over to that one. Yeah, black color we have to choose. Yeah, from this. Draw a border line. Try to see, first we have to draw a border line onto the drawing sheets. I tell you, what about the margins? Yeah, this is the borderline we have to draw on drawing sheets. Yeah, if you start any drafting, that is drawing, you must set your scale, any one of the scale. Say here, the scales. Yeah, I think this is not parallel now. Yeah, try to look at this picture. Yeah, here this is not parallel. So you have to put your scale parallel to any one of border edges, any one of the border parallel. So you have to set. So you have to set parallel. So after set parallel, then you have to start to draw the drawings. Yeah, here we are looking, we are talking about only drawing sheet layout. What about the margin? Yeah, if you take the margin, yeah, from this, yeah, this is 10 mm, 10 mm. Yeah, from the edge of drawing sheet, this border, that is bottom border line, should kept at 10 mm. Yeah, similarly from right, yeah, this is 20 mm, 20 mm, this one 20 mm, and the other three border lines are spaced. Yeah, this is 10 mm, yeah, this one is 10 mm. All sides are 10 mm spaced from the edge of drawing sheet. Yeah, next one you have to give your details, but probably in our sessions we are using 100 mm length and 90 mm height. It depends upon the use of details in that column, that is called name block. Yeah, here again I choose a scale for 100 mm, that is 10 centimeters. 10 centimeters I want to draw, but the height is 90. So I want to choose the height first. Yeah, for this difficulties only you have to use mini drafter scale, because two scales are perpendicular to each other, but in this package of open board, we are not able to get mini drafter. So, I just use only scales. Yeah. Try to see, measure 90 mm, that is actually 90 mm is more, is it? It is very big. So, it is enough to 50 mm, we have to shortcut. Why we go for more than? So, 50 you have to take, then put dot. Okay. And now, this scale again bring into original, that is parallel to this. Set your mini drafter, okay, mini drafter scale parallel to this, okay, any one scales set parallel to any one of the border line. Then draw a horizontal line for the height of 50 mm. One more thing, I want to put this for 10 centimeter, that is 100 mm. Then draw a line for 100 mm. Okay. So, then we have to join this line. Try to see. This one. Next we have to subdivide it. Okay. You have to divide this into many number. We are allotted is it 50 mm. So, 50 mm is more, then we have to do a segregations each 10 mm. So, why we need to each 10 mm to segregate this? Because we have to give a details, what details we have to give. In engineering graphics we are not able to give much more, but in this column, in this, that is in this column, details, okay. So, this column should be differ by different layouts, but you have to chosen any one of the layout and start it. But normally in our sessions we are using 100 mm by 30 mm. So, why we are chosen 100 mm by 30 mm? In this again we have to draw a line, is it? So, there is a guideline, this should be try to see this. So, a thin line I want to draw, thin line I just want to draw as a line, okay. Why we are using thin line? It is a guideline to print a letter using guideline only. That we have to learn later, but I have chosen the scale to draw this line. Here a thin line I want to draw as a edge. Again, because 2.5 mm approximately, not exactly 2.5 mm, then 2.5 mm below, that is 2 mm, 2 mm, 6 mm height. So, we have to chosen 6 mm height normally, in this. Approximate, okay, it not exact, approximate, but in any layout this should be fixed, okay, that is printed one. Then this is also thin line. Then to divide another particulars, then we have to choose thick line. Try to see here. This is in first column we are using around 2 mm gap, in this also 2 mm gap, and this remaining 6 mm to print text. So, name, who is the developer, who draft this drawing, so their name, and further details should be segregated in this manner. This is called details. Yeah, in our engineering graphics and drafting, this particular is named as a name block column, name block column. This is, but further there are many number of divisions in around the border lines, so that you have to learn in further, but this is enough to give the definition as well as the discussion of drawing sheet layout. But this is normally using in our classroom practice, but there are a lot of layout designs are there. So, that should be help in your advanced drafter. Okay, that is a drawing sheet layout. Yeah, many number of drawing sheet layouts are there. Yeah, next one we have to learn about lines, because this is important, is it? While you give any draft on drawing sheet, that should be in a line or part of circle and so on by using pencils. But here, yeah, what about this line? The various types of lines used in drawing, because to identify or you have to define particular, yeah, this line type shows visibly, yeah, this particular line type shows invisible, this is for construction, yeah, this is for imagination, like different types of lines are there, and also priority. So, which line should be you have to shown, because many number of objects, yeah, if you have any objects, that objects having visible edges, yeah, in parallel to behind there is a invisible edges, yeah, in between these two there is a axis line, okay, and also the construction lines also comes in that. But which is the priority, which line you have to show here, that is important, that is priority. So, priority is given to which types of line. So, if it is visible, that is the priority. So, next one invisible edges, then axis, then construction line, because construction line only brings our ideas and thoughts in the form of some shapes. So, that is why here we are classify the lines in difference. So, how it to be differ? By the appearance, by thickness and the way of constructions. Okay. Yeah, try to look at these types of lines. So, yeah, try to see in the first one, So, in this, yeah, again I go back and come, yeah, try to see in this, yeah, here if you take this, try to see this one, yeah, otherwise I have to erase this and go back and come. I change the colors. Yeah, these lines, try to see what I am shown here. Yeah, this is continuous, okay, there is no broken, okay, there is no discontinuous, it is a continuous, and also look the edge whether it is very thin or thick. So, if it is generate the line continuous and thick, that is description, okay, here given. So, for what purpose we are using? It makes visible, yeah, this is visible edges, yeah, this edges gives idea about the object. So, a general application where we have to use this, yeah, A1, yeah, here visible outlines and edges, for that purpose we are using continuous thick edges. Yeah, what about the second one? Yeah, here, yeah, this one, it is also continuous, there is no discontinue, continuous, but if you look about thickness, very thin. So, why we are using? Many purpose. Yeah, while you doing any drafting, so that should be initially generated with help of very thin line. Why? Not only thin line, you cannot impress, you cannot stress the pencil much more. So, if you stress or impress, so whatever it is that should making the tracing, that is impression on the paper. So, even though erased, then what you did in the previous, that impression is retained there. So, we have to draw before confirm the exact shapes. So, you must use 2H pencil, and not only that, continuous thin line without highly impressing, slightly impress, okay, do not impress much more. So, only you have to look that line. Anybody else looking outside, say for example 1 meter away or just 0.5 meter away from your drawing sheet, if they are looking your drawing sheet, these lines never visible to them. So, that is the use, because while you erasing, it not damaging your paper. So, it is easily removed, and your chart should be look very clear. So, that is the purpose. Yeah, try to see what are the applications. Yeah, here continuous thick should be applied imaginary lines, because while you find out any construction details, say to determine the intersection point, center point, or division line, or bisect line, many number of things together too. Yeah, that we have to learn in further chapters, that is next sessions in this, that is geometrical construction. Yeah, try to see dimension line, projection lines, leader lines, so hatching lines, outlines, yeah, short center lines. So, like different things here, is it? Try to see next. Yeah, continuous thin freehand, but it not straight, but it is a freehand, it not straight, it should be, yeah, it is also, but it should be some freehand sketch. Okay. So, why we are using, yeah, lines of partial views and some sections, then continuous thin with zigzag. Suppose why we are using some shorten, if you have very lengthy one, how to show in shorter pages. So, that is broken edges, then dashed thin, yeah, it is also thin line, yeah, it is used for hidden edges and outlines, yeah, chain thin. So, big dash, small dash, big dash, small dash. So, why we are using, it is used for center lines, lines of symmetry, trajectory. If you show any path, you cannot show as a continuous thin, you cannot show as a continuous dash, but there should be a big dash and small dash. So, it look at as different, that shows whether it is a trajectory or lines of symmetry and center lines. Then chain thick, thick and thin at ends and changes of directions, yeah, it will show the cutting edges. So, if you shown this particular types of line, then it will gives idea. What idea? So, here we are make some section, this section determine in somewhere else in this drawing sheet. Yeah, similarly chain thin double dashed, yeah, it is also used for some other purpose. Okay. So, what about the priority? In what order you have to chosen? Yeah, first visible outlines and edges. So, what are the edges you have to draft that should be visible, that you must put it in continuous thick. Then hidden outlines and edges. Yeah, if you are not looking about the edges of object, yeah, then what line you have to do it in draft, that is outline. You have to look, is there any outline of, or if there are any hidden lines in particular objects while you draw, that you have to generate, that is dashes. Okay. Continuous dash, not continuous line, it to be a dash lines, then center lines and axis of symmetry. So, this is the order you have to draw in your drawing sheets. Yeah, most important, but also you learned, yeah, everyone aware. So, in any language, if you take, first thing you have to learn about alphabets. You know what about alphabets, but whenever I am taught about these subjects, I never talk about alphabets. I just say symbols. Why? I just move on next page. Yeah, so I repeat this. Okay. Okay, I rub this. Yeah. I rubbed this pages. Okay. Okay, I move on to next page. Yeah, page 1 I just make, okay, undo. I move on next page. Okay. I said what about lettering, but I just pronounced symbols. Yeah, any language, you have to take any language, Tamil or English or any kind of languages, if you follow, okay, not at all problems, but how to we learn symbols. Why I am telling this? Yeah, if you put letters this, we are named as a letters in language, but we are following graphics. In graphics, we are talking about symbols. So, these symbols are grouped under alphabets. Yeah, say number 1, 2, 3, these symbols are grouped under numbers. Okay, these are alphabets, but we have to learn about the symbols. What are the symbols presents? So, yeah, any kind of symbols, okay, you have to take. That's here we called as a lettering. Lettering. Yeah, here. So, what about lettering? You just whatever it is, you are looking that symbol, what it gives, what pronunciations, etc. But in our universal language, that is engineering graphics, how it helps? Yeah. So, the lettering helps us in different ways, okay, the ideas and thoughts and different views, and also where it is, how it look, in what position we have to make it particular drafting. So, that is the objective of this lettering. Yeah, here in this lettering, yeah, in an engineering drawing, lettering plays an important role as it explains those parts of the object, so which cannot be shown by lines, because if you are giving a letter A and B, that named as the edges. If you are tell about only point A, yeah, just I pronounce this as point. So, if you put A, that is point, then if you construct a rectangle, okay, if you are named ABC, so it is a triangle, okay, ABCD rectangle. This name of group of letters itself gives some pronunciation. So, that is, on the other hand, the poor lettering not only mars the appearance of drawing, but sometimes leads to wrong results, which cause waste of time and labor. Yeah, thus the lettering is the talk of drawing, and therefore it should be legible. Yeah, it is very important, legible, neatness, uniform in appearance, simple and easy for rapid writing. But actually this is the introduction, but what about the definition? The art of writing the alphabets, say for symbols, that is A, B, C to up to Z, and numbers 1, 2, 3 and 0, etc. is known as lettering. But actually we are I grouped under symbols, okay. The art of writing of symbols such as the alphabets and numbers is known as lettering. Yeah, there are many number of objectives. So, what it is, why we go for? Yeah, requirements of good lettering, that is the purpose we are go for lettering. General proportions of lettering, there is a general proportions, how to follow the letters, how to sequence the letters and etc. composition of letters, how to combine together, then spacing of letters, size of letters, uniformity, guidelines, guideline devices, stroke of letters, classification of lettering, mechanical lettering and pencil for letterings. Okay. There are many things, try to see one by one. Requirement of good lettering, try to see the knowledge of shape and the proportion of each letter, the knowledge of order and direction of strokes, the knowledge of general composition and so on. Here the proportion, is it normal lettering, condensed lettering, external lettering. So, what about normal lettering? This is, try to see in the beginning the screens, there is a graphics is going on, is it? Try to see, it is a normal, the spacing between the one letter to another letters. If you go for condensate, you have to compress, that is the spacing between one letter to another letters. So, this is condensing, that is condensed letters. What about extend? You give some space, more space, that is extended. So, it is called as a proportions. Okay. What about the composition of letters? You have to combine together to form a sentence. Then spacing of letters, everyone knows what I said in the previous, the similar in this. So, you have to give a space and properly for every lettering. Then size of letters, uniformity of letters. Here important notes, try to look at important note, that is important. The uniformity in height can be obtained by drawing guidelines. There are different guidelines we have to generate. Say for example, if you want to mention, give title of your drafting. So, you have to produce a guideline, that is text height, guideline for text height. So, around 8 mm to 10 mm approximately, okay, but you cannot choose exactly. So, approximately 8 mm to 10 mm is enough to give your title of your drawing, okay, that is on the drawing sheet inside the layout. That also comes in layout. And if you give any subtitle, that should be in 6 to 8 mm. Then name of, if you want to draw any name, if you want to give any name, then you have to chosen 6 mm or 4 to 6 mm, but normally 6 mm is enough. So, different height is given for different topics you have to follow in drawing sheet, okay, that is important. That is why the uniformity in heights, the uniformity in inclination, the uniformity in spacing, uniformity in strength of line, that is thickness, but you have to produce only thin, not thick. Guideline, it is important. The lines which are used to regulate the height and inclination to the letter are known as guidelines, because it guide you. The guidelines are used to regulate the letters uniform. The guidelines should be drawn with 4H to 6H pencil, but normally we are using 2H pencil. They are telling 4H, but 2H is enough. 2H is hard, but if you take 4H still hard, 6H more hard. I already talked in the previous sessions, that is introduction, under the topic of instrument, that is drafting tools. In pencil different varieties are there, 9H2, so 8B, that is grade of pencil. It is nothing but transfer of carbon particle onto the paper, that is pencil of carbon particle is transferred and looking as dark. Okay, more amount of carbon particle transferred, it is very darker. Okay. So, here 4H to 6H, but normally we are using only 2H pencil. There are many number of guideline devices are there, that is called template, that I already shown in tools. Here in stroke writing, how to write those alphabets, already learned, those who are learning of this subjects, okay, you know about how to write letters, that is alphabets and numbers. The same way you have to follow the strokes properly. Letters A, try to see, in this animations I have given how you have to produce letter A, where to start. Yeah, try to see the guidelines. There is a guidelines also. Guidelines also there. Try to see, there is a guideline in this. Yeah, try to see this guidelines. Yeah, guidelines is used to draw a line. Yeah, please note this line should be very thin, very thin. Okay, it not thick. Similarly here, but these two lines helping. The height of the text is nothing but the spacing between the lines of guideline. So that is called guidelines. Okay, yeah, in this how to sequence, how to stroke your letters in this. I understand. Yeah, I think you clear about these videos. Okay. Yeah, similarly letter B. So strokes number 1, number 2. Yeah, already you learned. Okay. So I can't repeat again, but from this animation you have to be able to understand. So how to produce. Yeah, how we are arranging the mini drafter, papers and so on. So that is the logics. C. Okay, how we have to generate the curve, the part of circles. Number 1, number 2, number 3. So this is the sequence or stroke to generate letters. Okay. That is the stroke of the letters. Yeah, classification of letters. Yeah, many number. Yeah, today's we have systems. In system, if you go and choose font, many number of fonts are there. That is lettering. Many types of letters are there according to language. Mechanical lettering devices, you know about what about mechanical lettering devices? Template, okay, no need of others. Yeah, the next one is most important in engineering. Yeah, everyone must know and use about measurements, not only measurements, also marking, because measurements you just pick the measurement from the object. So also you have to give the measurements where to mark. So that is why measurements is most important in engineering. Yeah, whatever it is, whichever the branches you have to chosen. But dimension gives. So what it is, it's also makes your draft legible, but it is gives ideas and thoughts to layman laborers. Okay, otherwise they cannot understand. Yeah, what about this diagram? What about the left side? How much size? How much location? Where it is from? And everything it's from this measurements. Yeah, now we are looking about dimensions. In this, the main aim of drawing is to represent the correct size of object to be manufactured or construct. It is therefore necessary that the drawing must carry the proper dimensions and other informations of the various parts of the object. The correct dimensioning will facilitate the technician in manufacturing the part, whereas the wrong dimensioning may cause confusion and will lead to a great loss of time, labor, material and etc. Therefore, dimension should be done in a way which is located simply and easily understood by the technician. So, what about the simple definition? The art of writing the various sizes or location, various size of location of measurements on the finished drawing, that is you draft, you give your lines and arc, all things in there, lettering also there. But what about the size? What about the locations? What about the measurements of that particular objects? So, after finish your drawing, then you have to do this dimension. So, that is called dimensioning. Yeah, in this, yeah, we categorized, okay, notation. So, how to follow, theory, units, then system of placing, where to place, there are general rules, yeah, notations. Yeah, what about in this notation of dimension, the notation of dimensioning consists of dimension lines, extension lines, arrowheads. Try to see here. Look about this. Notation. The notation of dimensioning consists of dimensions. Okay, dimension lines were here. This dimension lines. So what about these dimension lines? It looking this. Already I said dimension line should be continuous thin. There are two ends, and extension lines. These two ends. This is extension lines. Extension line. Extension line must be perpendicular to the dimension lines. Sometimes you have to oblique. Then this is, try to see extension lines and arrowheads. Arrowheads here we are following, is it? There is some logic. So in this, arrowhead must be 1:3. Normally we are following. What is the logic of this? That is 1 times of width. 1 times of width. If you consider that. So what about length? This length should be 3 times of width. 1:3, proportionate. So what proportionate here we are talking? You have to take some lines. This is the line, dimension line. At this end, extension line, perpendicular. Suppose I want to draw a arrowheads. So how to draw here? In this corner, then you have to extend, then close and shades, fill. Then you have to fill. This is arrowheads, but what it talks there? This is L. This is nothing but W, width. Okay. So if you produce, the length is, what about this length? 3 times of width. So this is the proportionate, proper arrowheads. Suppose if you do it like this, if you are having like this is right, this is wrong arrowhead produce. So arrowhead also important. It will makes very legible. Okay. So 1:3 you have to follow, that is W is to L. L is 3 times of width. That is the proportionate you have to follow for arrowheads. Then text and numbers. Suppose you have to take a lengthy. Okay. In this you have to draw a arrowheads and both ends. Then there are 2 dimension line, is it? But we have to draw a dimension line continuous, such that you have to erase. In middle portions and show. So what about the text? Say 100 mm, 100. But units, here units must be followed uniformly and denoted above the name block column. Above the name block column only you have to denote, otherwise it is not prompt. Okay. So here only you have to give the value of units. The units should print above the name block column by using a 6 mm letter height, that is guidelines spacing, that you have to draw. In that only you have to give. I show now. This is notation of dimensioning. This is notation of dimensioning. Here I just give examples. Okay, that is why. If you take any name blocks, this is name blocks. So you have to draw a guideline. because to pronounce the units, what type of units you have to follow in this draft, that is you have to draw a 6 mm, 6 mm, you have to draw a 6 mm guideline. This is guideline, thin line. Okay. So, in this only you have to print, in this only you have to print. Yeah, here you have to print. Understand? Try to see. Yeah, in this you have to print what? All dimensions. Dimensions are in mm. So, you have to print. Okay. So, all dimensions are in millimeter, you have to print. So, above the name block columns, yeah, what is this actually? Yeah, what is this? Yeah, this is going to be details, details about unit, what units you are following in this draft. So, that is you have to given commonly. Okay. Do not give in dimension itself, in dimension only symbols, any text or what value of units it to be, only that. So, that is under notation of dimensioning. Yeah, here again I come back, theory of dimensions. Okay. Size dimensioning and locations. So, what about size? Yeah, this is the size dimensioning. Yeah, here S tells about, here S is nothing but size of the object, L gives location. Try to see in this. Yeah, try to see in this. Yeah, in this S pronounced here, size dimensions, L pronounced locations. So, what it is actually, because what about the location of this center line? What about this location of center line? What about the center point of this circle from the center line? So, it just gives the dimension to locate the object, but it not gives what size of the object, but in above it just gives only size of hole. What about the size of hole? Yeah, it to be. So, what about the edge of this? Yeah, what about this edges? So, these are gives size of an object. So, that we are named. Okay. Yeah, it is a theory of dimensions. That is the location dimension and size dimensions. Then units of dimensioning. Okay. So, I said in previous, in similar it to be followed here. Then system of placing, yeah, it is also important. So, what about the object edges? So, normally it not vertical or horizontal, sometimes it inclined. So, how to generate, but how sequentially you have to follow. Suppose there is a horizontal dimension, there is a vertical dimension, in what sense you have to follow the dimension text, not dimension lines and arrowheads and extension line. The text you have to follow whether horizontally or vertically or aligned to, that is aligned systems. Yeah, in these aligned systems, try to see all dimension values should be in parallel. So, if it is dimension lines are horizontal, the text also, text or value of dimension also horizontal. If dimension is vertical, the text or value of dimension also vertical. So, this is aligned system. Yeah, here many number of types. Okay, I come back next. Then unidirectional. So, all whatever it is, whether it is horizontal dimensioning or vertical dimensioning, but the lettering place or text placing in that should be in horizontal, in only one direction. So, yeah, this is the example here. Try to look at the picture. So, that picture shows the units, the unit value of dimension or text that should be in placing of horizontal. So, that is the unidirectional systems. There are some general rules, but here in aligned system or unidirectional, so we have to follow types of dimension. Yeah, you have to learn this, because after complete your drawing, then you have to generate or produce dimensions neatly. So, what about the types of dimension you have to generate for our drafting? Ordinate dimensioning, linear dimensions, aligned dimensions, angular dimension, continue or chain dimension, base or parallel dimension, combined dimensioning, diameter dimension, radial dimension, like many numbers. Yeah, first ordinate. Yeah, what about these ordinates? Yeah, here try to see in this, just there is a vertical and horizontal line. So, the vertical and horizontal line just shown here, is it? Try to see. Yeah, try to, yeah, to locate the center points. So, what about this center point locations? But this ordinate dimension only for absolute. What is the meaning of absolute? Yeah, you have to refer 0, 0. You have to refer 0, 0 from the origin. There is a reference from the origin. Yeah, try to see here. We drawn this drawing from the origin itself. Yeah, from the origin. Yeah, from this. So, what about this placing of center point? Center point of the circle. So, what about 93? It's x axis or y axis? It's very important. It's tell about the y axis, the y value of, we have to note x comma y. Yeah, what about the points of x comma y of this center line? Yeah, x is following this 58, then 93, because from the origin the y value is 93, from the origin x value is 58. So, these types of dimension is called ordinate dimension. Yeah, you have to make it horizontal or these types of, both are same, but probably we are not using this ordinate dimension, okay, but it not much more help to us, because we are not refer our drawing sheet as some origin, but we have to draw any other, but without chosen of reference as origin in drawing sheet. That is why we are not using this ordinate, okay, due to these reasons. But if you chosen any one corner as origin, then you have to follow this system of ordinate dimension. Okay. Yeah, next one, linear dimensions. Yeah, try to see here linear dimensions. Linear nothing but either horizontal or vertical dimensions. So, in these pictures, okay, you have to learn how the dimensions are placing. For horizontal, how it is placed. Yeah, even though there is a inclined line, for that inclined line, if you draw any dimension with respect to two ends, how it generate? You try to see. Yeah, how to draw this line? Yeah, you have to take scale. it not comes here, that is why. Yeah, this is one end point, this is one end point, this is another end point. Here by taking these two end points, from this you have to draw a extension line. This is extension lines, extension line, this is extension line, this is another extension line. Sometimes this extension line is vertical or horizontal, because we are chosen as a linear dimensions, okay. But normally we are draw this extension line from the object endpoints, but you have to give a space, you have to give a space between object points and extension line. Yeah, you have to give. Yeah, this gap should be normally greater than, okay, 2 mm, about 2 mm you have to chosen, don't choose less than 2 mm. But if you join that, if you join together, if you join this extension line to the end point, but it look like an object, so that is why we give a gap between object and extension line. So even though it is inclined, but the dimension should be horizontal, for that the extension line from these endpoints are vertical. In similar fashion for vertical dimension, here the dimension is horizontal, but even though this inclined line. So that is the logic. Or understand? Yeah, here we talk about linear dimensions. Yeah, aligned dimensions. Yeah, try to see. Yeah, in this aligned dimensions, again. Yeah, in this aligned dimensions, okay, what we have to see? In this aligned dimension, try to see here. Yeah, this dimension line parallel, dimension line parallel to that object edges. So extension line should be, what about perpendicular to that object, okay, perpendicular to that object, and also dimension lines. So these types of dimension we called aligned dimensions. Yeah, angular dimensions, yeah, we have to specify angles. Yeah, try to look at these objects, then you have to learn. So how angular dimensions are helps. Yeah, the angle between two edges, that is the bottom horizontal line and inclined line. So how much angle it to be tilted? 27 degree. So if you put some extension line outside to the vertical and 63. Yeah, here this one, yeah, this edges and this edges gives 27 degree. Suppose you have to calculate this one, yeah, this edges, so 90 degree, okay. But in this, if you want to draw, you draw a extension line and you have to placing. So what about, yeah, this side or that side degree you have to mark. So this is the fashions you have to draw a dimension line. This is angular. So angle specified for edges. So what about circle? In circle you have to mention some sectors, how much sector is this angle, and particular arc for arc. So what about the angle? So you have to mention or draw dimension line in this fashions, okay. Don't do it in horizontal or anything. If it is curve, parallel to curve. If it is an arc, parallel to arc. In such sense only you have to generate or produce dimensions. Okay, yeah, continue. Yeah, try to see, continue dimensions. Then base, yeah, here your starting point is common to all. The starting extension line of each dimensions are common, okay. Then second extension line is vary according to their measurements. So that is called base or parallel dimension, yeah, because the dimension line also parallel to one another, okay. So that is why base or parallel dimensions. combine dimension. Okay, you have to combine both. So not only continue. So continue is nothing but, try to see. So the first the dimension of 20 mm, the first one is not common to second one, but second one is common to the second dimension of first one. So it is continuous. Okay, but it is not continuous, it to be common to all, one base to all dimensions. Then it is combined. You have to do it in any manner. Okay, combinedly or separate, wherever what you like, you have to produce. But the genuinity is it rules. There are some rules how to follow these dimensions. Yeah. So diameter dimension. How to follow diameter dimension? Okay, there are certain rules. Okay. Yeah, in first case, second case, and third case. Yeah, here there are 3 circles are there. In 3 variety of diameter dimensions is possible to generate or showing on drawing. Then yeah, similar radial dimensions. Yeah, both are common. Not only circle, also it is common to arc, because arc is a part of circle. That's why the same manner you have to generate or produce for arc, the dimension, diameter dimension or radial dimensions. Yeah, try to look at this. Here also there is a 3 circles. Okay, for these 3 circles, how to generate radial dimensions? Yeah, in this fashions. Okay, now yeah, and there is one more general rules for dimension. Yes, it is important. Yeah, everyone must know. Okay, why? There are many number of general rules are there. All the dimensions necessary for the correct functioning of the part should be expressed. If you draw any part, that should be expressed proper measurements. So that is a very important rule in this. Then dimensions should be given on the view, which shows the relevant features most clearly. Dimensions marked in one view need not to repeat in another view, because if you give the dimension in one particular views, so no need to mark it or repeat in another views, that is unnecessary. So taking of times, not only that, also it will occupy some spaces. So that is why do not repeat. Yeah, dimension should be placed outside the view. Yeah, because if you have any object, so do not draw a dimension inside that. So mostly give that dimension outside the drawings. Okay, mostly. Yeah, sometimes it is not possible to give in outside. Then what to do? Yeah, in particular case you have to do it in inside. Yeah, try to look at here correct and incorrect. So what about the correct and incorrect? Yeah, in this, yeah, in left side correct following of dimensioning, in the right side. Why? The 48 mm in right side drawings, 48 mm is placing in object, because you have tell about the 2 edges. So that is incorrect dimensioning. And also look at the diametrical dimensions, say diameter 65, that symbol that is called diameter. Okay, 65. If you placing like this, that is incorrect. Instead of that, you have to tilt to show the diameters. Yeah, see, yeah, in this now, see incorrect and correct dimensioning. Yeah, left side, try to this incorrect, incorrect and incorrect. So what about the incorrect dimensioning? Yeah, here placing of dimension inside the object, inside. So it is incorrect. Yeah, in this the placing of the dimension horizontal. So, what I said, you have to do it in this fashions, okay, in this fashion only you have to do it. So, we are using this symbol, this is diameter, this symbol is used for diameter symbol. So, R is used for radial symbol, okay, yeah, here. So, this one is wrong, yeah, here try to look. So, why it is incorrect? Yeah, everything is outside, okay, everything is outside. So, 15 mm left side in outside and 57, 59 everything is outside, but what about incorrect? Yeah, you are showing this circle in 15 mm. So, why not you show it like this by 15 mm? So, it is incorrect. So, properly if you want to do it this, yeah, this is the proper dimensioning. So, by that you have to follow certain rules in dimensions. Okay. So, these are the dimensions. Yeah, now we are completed the principle of graphics here, but this is also important, that is why I am said in beginning. So, beginning of this session I said graphics principle is most important, because these things are promptly, if you did it, then your drawings is very good. So, producing of drawings legible makes goods, that is everyone to learn easily. So, that is why we are follow the graphic principles. The next one we have to look about geometrical constructions. So, because the important topics, okay, geometrical constructions, why we go for, yeah, we are generate some lines and circles, but how to generate or create some shapes, that is entities, primitives. So, we have to generate some primitives and entities, okay. So, how to construct, what about the geometry, what do you mean by geometry? So, this is the topics here we have to learn. Yeah, the first one with geometrical terms too. Yeah, what we known, yeah, triangle, quadrilaterals, polygons and parts of circles. So, what about the construction, what we have to construct? Yeah, there are a line, yeah, those lines how to bisect, there is a arc, there is an arc, how to bisect that arc, okay, and angle. So, similarly we are having many number of methods to make construction of our draft. So, that is given here. Yeah, in this first we have to learn about geometrical terms. Triangles, so everybody knows this is a triangle, what it is, there are three sides, but again there is a types. What about the types of triangle? Equilateral triangle. So, what about this equilateral triangle? Yeah, how to draw equilateral triangle, is it? Yeah, by using mini drafter and pro circle. So, we have to placing, okay, equilateral triangle, each sides equal and include angle, all include angles are 60 degree. Yeah, here I want to tell about include angle and exclude angle, okay. Later I tell you what about, yeah, try to see the measurements. Yeah, this is, yeah, try to look about this dimensioning, okay, how to draw dimensions for this. Yeah, in simultaneously I am telling about dimensions, horizontal dimension, aligned dimensions. So, then we have to draw a irrigate proportionately and both sides here. So, all sides are equal, all sides are equal. So, after did this text, then draw angular dimensions, okay. So, what about include angle? Yeah, here include angle is 60 degree, okay. Here include angle is 60 degree. So, what about that 60 degree? Yeah, now we have to learn about what is that 60 degree, how it is. So, include angle, Yeah, include angle. What about this include angle? Yeah, include angle nothing but, yeah, this is, try to see, this is include angle, that is between the two edges, but normally we are calculate, yeah, from the reference, this is reference horizontal plus x, from the plus x only we are calculate angle, that is exclude angle from the reference line, from the plus x. So, how much angle it takes, okay, for these edges. So, from this to this edge how much it covers, semicircle. So, 180. So, 180 minus, what about this one, number of sides, how many number of sides, that is 360 degree, total circle is 360, total circle 360 divided by number of sides, n is small n is number of sides, number of sides, how many number of sides for this triangle, 3 sides, yeah, substitute here 3 sides. So, what about this, yeah, for this triangle is it 120, then subtract, so it gives 60 degree. So, therefore, include angle formula, this is formula for include angle, 180 minus 360 whole divided, that is divided by number of sides. Yeah, if you take any other, that should be here, it is only for regular shapes, this is for only regular shapes, okay. So, exclude angle, what about exclude angle, this is, okay, if you take this, that is exclude angle is nothing but this one, exclude angle is nothing but 360 degree by n numbers. So, 180 minus exclude angle, okay, that should be here 120. So, this is the formula, okay, we have to use here. Yeah, next isosceles triangle. What about isosceles triangle? Try to see. We are draw 2 line, one is horizontal, another one is the vertical, that is mutually perpendicular, okay. So, that is isosceles or right angle triangle. Then scaling, you know what about scaling? Yeah, scaling is all sides are not equal. Not only that, include angle, there are 3 include angles are there. So, all 3 include angles are not equal. So, that is called scaling triangle. Yeah, now quadrilaterals. Yeah, what do you mean by quadrilaterals? Quadrilateral is nothing but 4 sides. So, what are the object, what are the entities, primitives have 4 sides. So, types square. So, what about the square? Yeah, squares, yeah, this is the square having 4 sides. So, include angles are 90 degree. So, rectangle. So, 2 sides are equal and include angles are 90 degree, rhombus. Yeah, this is the rhombus because 2 angles are 60 degree, 2 angles. Try to see in left side 60 degree is there, na? 60 degree and opposite both are similar, and another 2 sides, that is another 2 angles, isn't it? That is also equal. So, 60 degree and 120 degree, but all sides are equal, that is rhombus. Yeah, rhomboid, but sides are not equal. Rhombus, all sides are equal. So, 2 angles, okay, there are 2 angles are equal, other 2 angles are not equal, okay. Rhomboid, edges are not equal. Trapezoid, so 2 edges are parallel, but I am not talking about here, all sides are equal. Only 2 sides are parallel, but include angles are different. Trapezium, but 4 sides, but all sides are unequal. So, these are the types of quadrilaterals. Then polygons, it most important whenever you study about engineering graphics. So, here the pentagon, hexagon is most important. So, that is Yeah, what about pentagon? Five sides. So, 5 sides, it is a regular pentagon. So, include angles 108, yeah, try to calculate, include angle equal to 180 degree minus 360 by number of sides. So, 360 divided by 5, what it gets? 72 degree. So, 180 minus 72. So, include angle is 108 degree. Then hexagon, similarly 6 sides. So, here include angle you have to find 180 minus 360 divided by number of sides. Yeah, 360 divided by 6, you get 60 degree, then you have to subtract with that, then 120 degree. So, heptagon, number of sides, octagon, nonagon, decagon. So, like different polygons are there. Polygons is have combination. Yeah, that is the statement, okay, definition. So, what is the polygon? If anybody asking you, yeah, it is a combination of number of sides. Polyhedra is faces. There are different terms are there. Polygon, refer, sides. So, poly, refer, that is guns, refer, sides. Poly, refer, combination. Combination of number of sides is called polygons. Then part of circle. So, in that part of circle arc. So, what about this? Yeah, everyone knows what do you mean by circle. In that circle, if you take certain part, that is called arc, chord. So, the connectivity between the two endpoints of arc, then that is called as a straight edge, that is chord. Segment. So, only you take the chord and part of arc, both you have to club together and taken as a one sector, that is one part, not sector, one part, that is segment. Then sector, the sector represent the part of circle with respect to center point. Yeah, from the center point to a endpoints of arc, the total portion from the center point to the endpoints of arc, the total portion is nothing but sector. So, you have to learn the terms. What about in this? Try to see equilateral triangle. Yeah, I already shown. Yeah, geometrical constructions. But already I shown this, no? Yeah, geometrical constructions. Yeah, in this geometrical constructions, why we go for geometrical construction? To bisect a line, to bisect an arc, to bisect an angle, to divide a line, to find center of an arc. Yeah, we have to see one by one. To bisect a line. Yeah. Yeah, draw a line. Yeah, draw a line by using this scale. Draw a line. Draw a line. Yeah, how to find out midpoint? Yeah, there is a endpoints here, and there is a endpoints here and endpoints here. How to find out midpoint? Midpoint. How to find out midpoint? Yeah, that is bisect a line. Yeah, you have to take a compass. You have to take a compass. Okay. Yeah, you have to set in one. You have to set in one endpoint. Yeah, you have to put the needle end in any one point, and you have to take approximately the radius more than half of approximately. Okay, more than. You take it as a radius. Now make an arc above and below. You have to take it this. Okay, now we have to make an arc above. Okay, but actually this is coming from line, is it? So, undo and come back. You are placing this. Yeah. So, I have to chosen the direction. Okay. you make an arc. Okay. Similarly, in bottom, similarly here bottom, in bottom also we have to place here. So, above and below you have to draw an arc by keeping the needle point in one end. Without change of the radius, then you have to shift to another end point. In this another end points, you just make intersection. You just make intersection. So, you just intersect. Okay. In similarly in another directions. So, you make intersections. Intersect. Now, draw a line, that is construction lines. Now, construction lines. You are keeping this here. If you draw a line, that will bisect. Now this is called bisection line. Bisection. This is called bisection line. This portion shows midpoint of this line. Normally we are talk about bisected line. So, what about an arc? In similar fashions, if you take any arc, if you consider any part of circle, if you take any part of circle, in this I just erased this arc. So, what about for this arc, what about the center point? How to find out the center point, how to bisect this? The same fashions, in the same fashion you have to take this, in the same fashions you have to take this into one end point and draw a arc one end point. Okay, needle point is here. Then we have to draw keeping that an arc. Try to see these objects. You have to extend. Without change, you have to move in another point and draw an arc, part of arc. This intersect point. Okay. In similar fashion, above you have to draw an intersect point. Those if you join, that will shows the bisect of an arc. So, this is the logics, okay, we are following here. So, how to managing? Yeah, to bisect on arc, to bisect an angle, yeah, similar fashion, to bisect an angle, to divide a line, to find center of an arc, yeah, yeah, to bisect an angle, to divide a line, to find center of an arc, yeah, we have to see one by one. We have to see one by one. So, what it is? Yeah, first to bisect an angle, yeah, we have to draw a line. Yeah, there is a 2 line. Yeah, this. So, how to bisect an angle? Yeah, there is an angle. Okay, how to bisect? Yeah, in similar fashion, you have to take compass. You have to take compass and keep it in this end. In this end, and you have to measure more than midpoint of this one, okay, or you have to take some more distance, okay, yeah, more than midpoint of each lines, then shift this needle point to this end point, another end point, is it? Now it changed. Now make an arc. Make an arc, yeah, without change of this radius 19.3 centimeter, then you have to shift this needle point to another end point of line. Yeah, now draw an arc to intersect the previous. Okay. Yeah, now if you join these two, but using this scale, yeah, using this scale, yeah, using this scale. So, you have to join. So, otherwise straight line, is it? Yeah, this will shows bisections. This is angle, yeah, this will equal, yeah, if you take this is theta, this is theta by 2, that is bisect an angle, okay. With the help of this by constructions you have to determine. So, what about the half of the angle of these two edges, that is the meaning. In similar fashions you have to determine center point of an arc. Yeah, now we have to draw I have to draw an arc. Arc. So, this is a part of a circle, that is an arc. How to determine center point? This is center point, but by using this its center point, it's okay by compass. But if you have this an arc, how to find out the center point? Yeah, for such case you have to draw a 2 straight edge in this 2 straight edge. 2 straight edge, yeah, we have to draw a 2 straight edge. Yes, two straight edges. two straight edge you have to construct in an arc. For this you have to find out bisection line by using compass. By using this compass, here by using this compass you have to generate, from this you have to draw an arc and above, and similarly from this point draw an arc to intersect and above and below. In similar fashion you have to draw an arc on both sides, and from this point draw an arc to intersect. Then if you join these two line, if you join the bisect lines, it comes along these centers. This is the way to find out the center point of an arc. So constructions to determine the circumference and regular, mostly to determine the circumference of a circle. Normally I just do it in free hands, due to some. You have to determine this circumference, because due to insufficient of space I just show it in free hands. There is a circle in the center point, try to find out. From this draw a vertical line and horizontal line, draw this vertical line and horizontal line. Here, so from the bottom of this end, from this bottom you have to draw a line. From this bottom we have to draw a line. This measurements as 3D. So diameter, D is nothing but diameter, 3 times of diameter of taken circle. So that is the length of this line. So afterwards then draw a 30-degree angle line from this point, 30-degree line. From this 30-degree. This is 30-degree line. So you have to draw a 30-degree line from the vertical. From the vertical, top vertical, from center point of circle you draw a 30-degree line. So from this draw a horizontal line. From this draw a horizontal line. Draw a horizontal lines. If you join these two lines, if you join these two lines, just a moment. If you join these two, this line gives pi d, circumference of a circle. But simply I am do it and shown here, but insufficient of tools I am producing this. So actually if you want to find out circumference of a circle, you draw a circle and find out two lines, vertical and horizontal, from the center. In the bottom of vertical line draw a straight line, that dimension or measurement as 3 times of diameter. So then you have to draw a 30-degree line from the center point, that is vertical, from the angle is from vertical to right side, that intersect the circle from the draw a horizontal line, again it intersect the vertical line above. So, from that you have to join the both ends, that is the end of 3 times of diameter, and this point that will shows circumference of a circle. So, this is the methods to construct to determine some measurements. Yeah, with this I conclude in this session. Yeah, thank you.